A line contains the points 1, 2, and 5, 0. What's the slope? Let's use a slope formula, y2 minus y1 over x2 minus x1. We have 0 minus 2 over 5 minus 1, which is negative 2 over 4, which reduces to be negative 1/2. What's the equation in the form y minus y1 equals mx minus x1? This is the slope point form. We can use either point. x1, y1 for the first part, we use 1, 2. y1 is 2, and x1 is 1. And for the second equation, our y1 is 0, and our x1 is 5. Now let's find the equation in the form y equals mx plus b, the slope-intercept form. We previously found the slope was negative 1/2. We know the slope-intercept form, and we substitute m equals negative 1/2 here. Now we substitute either point. For example, we can substitute the point 1, 2. The y value 2 goes here, and the x value 1 goes here. The rest is algebra. Negative 1/2 times 1 is itself. We throw it over, it becomes positive. 2 plus 1/2 is 5 over 2, which is our b value. Thus, y equals negative 1/2 x plus 5 over 2. Now, what are the intercepts? Intercepts are plural, so we need the y-intercept and the x-intercept. To find the y-intercept, we recognize it here, 5 over 2. We find the x-intercept by setting y equals 0. 0 equals negative 1/2 x plus 5 over 2. We throw the negative 1/2 x over, and we multiply both sides by 2. We arrive at x equals 5. And the x-intercept of 5 implies that y equals 0. Now let's find this same line equation in general form, ax plus by plus c equals 0, where the coefficients are integers, and a is greater than 0. Previously, we had y equals negative 1/2 x plus 5 over 2. Now, let's multiply both sides by the denominator, 2. We have 2y equals negative x plus 5. But the rule says that a must be greater than 0. The coefficient of x, which is negative 1, we throw over. So we now have x plus 2y, and we throw the positive 5 over, making it negative 5, equals 0. As you can see, all the coefficients are integers, and the coefficient of x is now positive. We now have the general form.